Alright, so this is the most common problem I see some questions about, so I just wanted to solve one together. I think one of the hardest parts here is seeing the triangle in different ways, so I'm going to actually try to solve it two different ways, and then maybe one of these strategies will stick with you, if not both. Okay, so I'll solve it first on the left, and then I'll solve it a different way on the right. So sometimes what I like to think about this is I often choose to think about the sides as being matching. So that's what I'll show for the first strategy. So I can see right here, this large triangle, the height of the triangle is 21, and the height of the small triangle is 17. So I'm going to set up a ratio like this. Okay. Now I need to match it for the next part. So if I use the large triangle for the 21, and that was the height, I now need to figure out the length of the large triangle. And it's really tempting to just say 3. But really, that's not a triangle. That's a quadrilateral. So I have to go all the way from here all the way across, which means 3 plus something we don't know. That's x. So 3 plus x. Or you can write x plus 3. So this is the big part, length, height. Okay? So here's the small height, and the small length would be x. Now that can look really intimidating. We've talked about cross multiplying as a strategy that works. If you're not sure about that, ask me a different way to explain. But I'm going to show this now with the cross multiplying. Again, what I'm saying is we've proved that this times each other is going to be equal to this times each other. So 21 times x is 21x equals, now I have to do this part over here, so 17 times 3 gives us 51, and don't forget we also have to multiply at both parts. We have 17 groups of 3 plus x. So 17 times x is 17x. Okay. Let's solve here that next piece. So this is now just some algebra. Minus 17x from both sides. We get 4x equals 51. I just made this problem up so it does not look like it's going to be even, but that's okay. X equals 51 divided by 4, and we get 12.75. Let's check and see if this is reasonable. So right here, the small triangle, 17, 12.75, 3 larger to get 21. This seems to be a reasonable number. Okay? Alright, now some of you tell me we do that and that doesn't make sense at all. So let me try to say it in a totally different way. So I had a student help me see it this way, potentially. So I can see there's a little triangle. So let's just draw that little triangle here. Okay, and then also there's the giant triangle. Okay, I know these aren't really drawn to scale exactly, but they just help me as a visual to see. So sometimes what's really confusing is how to set up and see, like, how do you decide to add those or anything like that. So let's actually just get it on the triangles. So here, 17 and x. Okay. And then the large one, we see that 21, and then here we see the whole length is x plus 3. Now just looking at this, it seems a lot easier to me sometimes to write the ratio, and I'm going to write the first ratio about the first triangle and the second ratio about the second triangle. Let's see if that makes more sense if the first way did not. So let's put 17 over x equals 21 over x plus 3. Again, it could feel weird that these are both hanging out together, and they look like a lot of variables, and that can be weird, but let's just check. Height for the small triangle over length of the small triangle. Height of the big triangle over length of the big triangle. Okay, I'm going to use the same strategy we did before. 21x equals 17 times x is 17x. 17 times 3 is 51. Okay, exact same thing. You'll see, even though we did the problem totally differently, we still used all of our rules of similarity in the same way, so we should actually end up with the exact same answer. Now again, I don't care what strategy makes more sense to you. Use one that makes sense. If you like looking at the lengths, do that. Maybe you can even see these little triangle and the big triangle without drawing them, but this could be an anchor for you to make sure every time, like, you don't forget to add x. Or sometimes there's two numbers here, then don't forget to add them when you write that second proportion. Let me know if you have other questions or a different problem that you like to solve. Hopefully that gives you at least a framework to look at it a little bit different way.